Let us now start the third and last part of this course on resource efficiency. 80% of overall effort to reduce environmental impact has focused in the past on the 20% of the total risk. If we look at the life cycle of products, from extraction of natural resources via transportation to manufacturing and then via production to consumption, we observe that the hotspot of their environmental impacts is not always in the manufacturing stage, where most efforts have been traditionally positioned. But it can be the mining, for instance, and the environmental impact of mining critical raw materials can be reduced by recycling, which depends on the willingness of the consumer to collect them. And critical raw materials can help to reduce the environmental impacts in the use phase of cars, for example. Striving towards resource efficiency is possible by decoupling resource use and environmental impacts from economic growth and human well-being, focusing on taking a life cycle perspective and doing eco-design as new product-oriented strategies, understanding consumption patterns, and applying an integrated approach to sustainable consumption and production. In this figure, critical raw materials are positioned in the DPSIR indicator framework, where we consider drivers, pressures, state, impacts, and responses to assess environmental impacts. Pressures on the environment come from resource use in the form of materials, including critical raw materials, land, water, and energy. These pressures are changing the status of various safeguard subjects: climate, biodiversity, human health, and supply security, which is particularly relevant for CRM and not an environmental parameter. The use of critical raw materials is often done with the aim to mitigate climate change. In order to measure resource efficiency, we have a number of input-output flows-based industrial ecology assessment tools. The three most important ones are life cycle assessment, material flow analysis, and environmentally extended input-output analysis. In all of them, CRM need to be considered to measure their contribution to sustainable development. Resource efficiency provides a win-win situation. At the economic level, it delivers cost savings, and at the same time, it generates environmental benefits. This is because raw materials have to be purchased, and all emissions and waste flows mean losses. Moreover, these losses need to be treated, such as wastewater, which has a cost similar to taxes as for landfill or carbon emissions. In summary, resource efficiency is about doing more with less resources and with less environmental impacts in order to allow the sustainable development of humankind within planetary boundaries.